All right. Hello. It's great to be here. My name is Mike Brevoort. I am going to press record. I did that. This is, if you don't have kids, you have no idea who this is. If you do have kids, you don't know who this is, you should. What's up? Yeah, so this is DJ Lance. He's awesome. My kids love, I have these two little girls that love this show. Anyway, that was me. That was after like a couple glasses of wine. A couple glasses of too much, right? First two were fine, and then the other two led me to this. And this was like the remnants of a birthday party for these like 2-year-old girls. DJ Lance. I'll get into kind of who I am and sort of set the stage a little bit. But here's my sort of agenda. It's a bit of a hodgepodge. When I thought about, what would someone want to hear me talk about for Node, and things that I work on, I wanted to share some substance. Like, I've been working with Node for kind of a significant period of time. I've developed some opinions and some biases, and have sort of lived through sort of trials and tribulations. And I thought it might be, then I have this bias of saying, like, well, if I don't demo something and show a significant amount of code, then I'm sort of weak, right? Like, you can't demo live and build something, you're weak. So I'm kind of going to err on the side of showing you some more slides than I'd kind of usually show. But hopefully share some insights and sort of some tips, and just discuss, like, what I think of Node, where I think it fits, where I think it isn't a really good fit. And just sort of like really like not just how I think it should be used, but literally how I've used it, and like we've used it in production and sort of real situations, and sort of live through and talk about some of those sort of tips and highlights. So, who am I? I currently live in Denver, Colorado. I've been there almost 10 years. I work for Pearson, who, if you don't know Pearson, we're a big educational company, and historically a publishing company. So you might not know Pearson, but you might know like Addison Wesleyan and DK Books and Puffin Books and the Financial Times, and it kind of goes on. There's lots of subsidiaries of Pearson. I came from, I wasn't there at the time, but there was a startup in the late 90s out of Denver, an education startup called eCollege, that focused on like software as a service back then, online education, e-learning, and Pearson acquired them about 5 years ago. So I'm married. I have 5 children. Which I still, like, I say that, and I'm like, I got 5 kids? Like, for real? I don't know how that happened. People ask me, they're like, don't you know how that works? And so I'll get to that later a little bit, but I don't want to jump ahead. And then, like, I look at the stat. I remember early in my career, I used to, like, you'd start adding up. You'd be like, well, I've got, like, 10 years experience, and you sort of add back to, like, that like 9th grade high school class that you did some whatever, and you're like, all right, well, if I count from there, I got 10 years experience. You sort of put that in a resume and whatever. You sort of like bolster the number. I'm at like the tipping point where I'm going to start to like pare back the number. I'm like, legitimately have like 19 years experience, and I'm kind of getting old, like, and it's hard, and I'm waiting to stop remembering things, but so far so good. And then but I've had this like history, and I've done a lot of things in lots of different languages and lots of different verticals and industries. And like these at least are the languages and the things that I've done stuff that actually has gone like to production and I've had to support. So like a pretty good variety of things. I started my career as like in the 90s, late 90s, as like a client-side JavaScript developer working, on defense contracts on some pretty awesome stuff that I still can't talk about. And then the web came, and I kind of really felt like this tractor beam pull of like, wow, I really need to do Java, and do some web stuff. So that's what I kind of did, and I went to Groovy, and it kind of went on. So I am also the co-organizer of Denver.js, which is similar to JSLA, and we actually meet in a really similar place. We meet at this place Galvanize, which is it opened in the fall, and it's the same thing, similar co-working space. It's awesome. They're awesome to us. Their director of community is also as awesome as Blair is. So really appreciate them and the opportunity to be here. So I'll jump in. 5 kids. 5 kids. Like, if you think about it, you're like, all right, we're going to go on vacation, so we're going to need 7 plane tickets. Like, think about that in your life. This is like a strange birth control commercial. But 3 of them are adopted. They like range from the age of like 2 to 8. So it's my life is just crazy, and if I start to stammer and fall off the stage, it's just somebody pick me up and prop me up, and I'll keep going, but it's a little nuts. So okay, Node.js Me, right? So I started to do Node work in the spring or so of 2010. It was about 0.2 then, and like they're working on 0.3. So it's been a little while, and then I've had like real production stuff running for about 2 years and I was at Pearson. So I've only been at Pearson for about the time I started working on Node. I did some stuff before then for about 4 to 6 months, proof of concepts here or there, but like no one was ever ready. And then when I got to Pearson, it was sort of this weird meeting in sort of ripe ground, and we found a pretty good use case to use Node. And then I'm also like, I'm generally an app maker and not a module maker, right? There's a big difference. Like, I've got like I got stuff on GitHub. I open source like modules and stuff, but it's like I got just this backlog of if you have a pull request that you're waiting me to answer, I'm sorry, I'm probably not going to get to it. Like the most popular thing I think I have is this like Facebook friend selector. It's like a jQuery plugin that for some reason it was like at the right time and place that like everybody used on a bunch of sites. But I got some Node stuff in that, but I'm just not. I'm just busy, but I tend to make apps, and then I like really making apps. I don't have as much fulfillment making modules. I mean, you get some fulfillment when people use modules, but I like having real end users that I can tap into and solve real problems, and that's sort of the way. It's just the way I am. So Node, right? So I guess, like I said, my background was I came from doing lots of like object-oriented C and C++ development. I was like an electrical engineer in school, so I did a lot of like, kind of dabbled even there with, I remember when I found C, I was like, oh, I could like, because I was taking all these classes where you started out just writing raw assembly code to, like this Motorola 68HT11 like evaluation board, and you're kind of like, how do I do reverse polar math? And then we found this, like, we got this other class, and then, it was so funny. It's like when your parents sort of expose you to this whole thing, like they make you do this other thing. I can't really think of a good example right now. And it sucks. And they're like, oh, I'm sorry, I got to do that. And then all of a sudden, they're like, happy birthday, here's this new thing. And you're like, why did you make me do that other thing the whole time? Like, when I could have used this. So, like, once we started writing things in C, it was amazing. Like, it was awesome, because, like, I could actually do things and write something and comprehend it and change it. And then, good Lord, I remember when I found, like, CGI. And I was in, like, college at the time. And it was like, you mean I could write this one Perl script that when somebody opens up Mosaic, they can put a URL in a port and it just returns them that thing, like HTML online, and I could, like, it's not just static, I can do dynamic things. And it's kind of funny to think back to that time, because like all the stuff we do today, Ajax, right, like a lot of the browser capabilities, like you could actually do back then, maybe not Mosaic, but it's pretty damn close. I mean, you couldn't really scale it that well, like the one process per request thing, wasn't necessarily that scalable. But so this is this curve of sort of joy, right? And then I remember I found Java, and I was doing servlet work and JSPs, and this was like around the turn of the century. And that was amazing too, because you're like, oh wow, it's awesome. I can write this like servlet thing that takes a request and response, and I take it and I parse it and I respond, and like create this big object-oriented thing. I worked at this place where they had this. They started out with like this high-level base servlet, and then it was like the second branch of inheritance, which was it was like authenticated and not authenticated, and then there was 8 levels. Not both sides. The unauthenticated was, but the authenticated was 8 levels. It was this bank. We had this 8-level, 8 hierarchy inheritance for this servlet, and man, they designed the hell out of that thing. But then it was like you kind of got to this point where you're like, it feels like we're just doing the same thing over again. And you had struts and some of the other web frameworks that sort of came out, and then, good Lord, I remember when I found Grails. I was managing this team. I was doing all Java development. And I kept saying like, it cannot take us 3 months to build this stupid CRUD app for like internal customers. Like, we have to find a way to do it faster. And they're like, well, we're using Java server faces. And it sucked. And I remember I laid Grails, right when Rails came out, I was like, this is it. This is amazing. Like, look, you can define this database schema, you do the scaffolding, you get all this stuff for free, and then you just start, and they kind of revolted on me. They were like, not one more thing. So then I found Grails, which was sort of inspired by Rails, but sort of the same thing, and it was easier at the time. Then I started did a bunch of consulting, and it was easier to get Grails deployed in places because you could say like, hey, it's your Java J2E stack. Go here. Here's this war file. Go and deploy it if you're familiar with that at all. And we're like, I'm sorry, it's 55 megs. And like, why is it 55 megs? I'm like, don't worry about it. Just there's like JVM like increase the perm gen space. Just don't worry about it. It's just a jar file. And but you had this like serendipity where I kept going through my career and it was like, you kind of get frustrated and you're like, I wish we could just do it better and faster. And then like, once I found Node, it just kind of blew me away because it was both very low level and sort of high level. Like I think Matt Rainey says it best from Boxster, and he's like, Node sort of puts the magic in the right places. So I mean, and the same kind of serendipity. You're like, I don't need an app server, a container, anything. I can just start this thing up. I can write, you see this typical Node examples of here's your 10-line, like IRC chat example or whatever, But it's awesome, right? You could very easily bind to a network port or over HTTP or even HTTPS, take some requests and respond to something. And when you start the thing up, it starts up almost instantly. And at like steady state, it consumes about 10 megs of RAM. And it was just awesome. And I mean, literally, like, I don't know where I am on that curve. It probably is sort of like at a zenith. Maybe I'm just going to go downhill from there. But like, it's not like I'm like, this is still awesome. It's probably more of a step curve or something. I'm waiting for the next thing. But anyway, that was kind of the attraction. By the way, if you have any questions, if you want to yell like bullshit or something, right? I should probably set some ground. You can only have 3. It's like the NFL, right? It's like you got 3 flags. So throughout the whole thing, save it. If you want to yell bullshit or something, go ahead. We can address it, but you got 3. But yeah, if anybody has any questions or anything, just chime in. I'm pretty easygoing about this. The drawbacks? I'll actually get to that a little bit. I don't know if that counts as one or not. I don't know what the rules are. It's like, all right, well, maybe it doesn't. Yeah, it's good. I love the participation. So I was trying to find a talk that I would call like blue collar programming, and I built this image, and I wanted to just show it. Like I put it in here. It was from like the Pennsylvania Railroad or something, because that's what I think of when I think of Node. I think it's like, it's not this glamorous thing that people are like, that's the most amazing tool to solve computer science problems. Like, it's perfect. It's Erlang, but not, it's kind of rough around the edges. It does what it does really well, but it's sort of like, you're like, wait a minute, you're telling me you took this thing in the browser, V8, and you strapped this layer on top of it, and we run, like, that's what and you're running JavaScript? Like, and you think that's a good idea, But it is, I mean, it's a thing to get done, honestly. All right, so what is it good for? In my opinion, okay, no, everybody's entitled to their opinion. This is all in my opinion. So the good. So I think Node really fits well and has fit well for me with I/O-bound type programs, right? If you know anything about Node, it does nothing well. Like, it literally does nothing well. So at a steady state, when it's not doing any work, it does that really well. And if it can separate itself from waiting, meaning it doesn't do any work, versus waiting is I spin my CPU and wait for that thing to happen, that's like the serendipity. So Node does really well at I/O because it takes it and then sort of, initiates it, and then as it's waiting for a response, it doesn't really have to do anything, right? So if you have applications that you're building that are very heavy on I/O, especially like HTTP type proxying situations, it's a very good fit there. And because of that, it fits really well in these situations where you're doing like API type aggregations, filtering, data normalization, like proxying. We've had like great success using Node for that kind of stuff. Mention that. And then we've also used it as like this edge server for client apps. Like when I came to Pearson, there was this phase of building these heavy like single page client-side apps that just talk to servers with just raw APIs, and it turned out a lot of those APIs were very granular, and it was super chatty between the client and then the server, and a lot of times it'd be fine, like in the perfect situation, but then one thing would go wrong, and it would just be like this house of cards that would be like, and things would slow down significantly. And we really like to use Node in situations, even where we don't need it that much, to have a sort of a place, like if you have an app. Instead of building apps that way, even though you're like, well, it's pretty much a client-side app and it's just all the APIs, to have something in the middle that you could use for, optimization, caching, whatever the hell you need to do to make your app sort of fast, performant, and tolerant. And then, streaming. Everybody hears, streams are like the belle of the ball of like Node or something. But streaming situations where you're taking I/O and you're sort of not buffering the whole thing and funneling along, good for that. As well as like systems type programming, where Node, because it has a pretty low overhead, like not the overhead of like Lua. Like Lua is like a tenth of Node or something, but the language is super accessible, right, and easy to write. It has an overhead of, it's about, I don't know what it really is, but it's about 10 megs. So for you to have like Node running as an agent on a server in the background, doing little things like shuffling data around, collecting metrics and stuff, it's pretty low overhead and easy to manage, right? It doesn't take up a tremendous amount of resources. And a lot of those things tend to be sort of I/O-ish and async, at least the things that we've built, and it turns out to be a pretty good solution there for us. All right, so what do I think it's not good for? This is bad. Again, it's in my opinion. Sorry if my opinion doesn't match your opinion. Oh no, Thomas. So the less good, the bad, less good, all the political correctness. I think like anything, and this is sort of obvious, like anything procedural, like literally primarily procedural and serial, where you want to say do this, do that, do this, do that. You try to do some stuff like that in Node, and you just fight it. Like unless you're not really doing anything significant, but if you try to write something that, like there are some things that Python's just really good for. Like if you're trying to write something, you don't want to write it in like Bash, and you're writing some system thing where you're dealing with like file system APIs and stuff, and you're literally like, make this directory, create this file in this directory, not put it on this server. And Node, you could do it in Node, but you end up writing these functions that do those things, and then you sort of wire it and glue it together with something like async or some async flow. Like you have to introduce this like other layer, whereas why can't you don't if like the FS like module in Node has a bunch of synchronous methods and stuff, and you could tie those together, but some of it's kind of limited in its functionality. I guess I probably should have started and asked like who's actually using Node. Like so who's used Node for anything? And who's like using Node in production? Like that's some badge of honor or something. You'd be like, yes, I'm using it in production. But so that's good to know. Okay. Who hates the hell out of the idea of Node? Anybody? Usually don't find that at like JavaScript things. You're like, that's the dumbest damn thing I ever heard in my life. Like, why would you do that? Problem solved. Okay. Good to know. Also like CPU-bound tasks, right? It's hard to manage some of that in Node. I mean, you could do it. You could Lloyd Hildale. I haven't got him to pronounce his name to me yet, or pay attention when I heard it. But he works at Mozilla, and he created the Browser ID project. And he created a module called Node Compute Cluster, and kind of talks through. He did a talk, I think, at Node Philly, where he talked about how he went through that scenario and creating that. And he found pretty good ways to actually scale Node to do very CPU-intensive sort of tasks while not bringing your app to its knees. Like the app that takes requests isn't the one that's handling all the work and tying up the event loops, like that actually goes off to these other pool of processes. But like you've got to just do all that work. Whereas there are things that you do in like Go maybe, or like even Java or some of the JVM languages that do like threading and real concurrency well. There's a sort of difference between parallelization and concurrency. In Node, you can do parallelization sort of just fine across different processes and scale it up across CPUs. But there's some things like that are just difficult. As well, I hate the term business logic. It's like one of the old buzzwords. People are like, well, are you doing business logic? If you are, then you need to be on a Java enterprise stack. We do business logic. But I mean, if you're going to do a lot of math computation, JavaScript at this current point in time may not be the thing for you, right? Like it doesn't do floating point calculations that well. It's got like, you can sort of stub your toe in places where, Python's got some awesome libraries for that and some other languages as well. And it's not to say that you can't do it. It's just that it's less good, I guess. The other thing that I came across is just like large code bases that can't be modularized, and usually they can't be modularized because the teams that design them, not because of the problem that's actually being solved. But I had this conversation about a month ago where someone that was very big Java advocate in my company, and they were like, well, I don't like Java because you can't refactor it. Like, I don't have my IDE, and I can't like right-click on a function name in their class and say rename it, and it goes and rename it everywhere. I say like, why do you need to do that? Like, why do you have your class being referenced in 100 different places throughout your entire application? Like encapsulation is sort of there for a reason, right? If you sort of have that and you can't really make sense of it, like once it gets behind, like you can't keep it all in your head, it's sort of what, I mean, I think Substack came and talked here, and he probably talked about like building small, module components within Node and sort of building with all these small, tight, sort of single or almost single-purpose things that are very easily testable that become these reliable building blocks. So in some cases where you can't modularize it, it becomes kind of a mess. Like if you have a really large Node code base, and we've even got an app like this that's sort of borderline on that, where you're like, we've got a whole bunch of tests, but we can't possibly be covering all these different scenarios, and like it just seems like kind of as this big ball of mess and we need to break apart. And it can even happen. It didn't start out that way, but it kind of grew into that. The second is just very large teams. Like when when you're like a single developer working on an application, like you can keep it all in your head and you can fly. And even if you have a kind of tight team together, it's kind of easy to keep it together. But once you get between like 2, 3 teams of people that are sort of independently working on pieces of this application, with JavaScript, as loose as it is, and some of those conventions that you defined, like it's not like it's more difficult than other languages to define like hard API contracts. Not to say it can't be done. I mean, it's done all the time with people writing public NPM modules you depend on, right? That depend on other NPM modules, but it's just more difficult, especially when those teams aren't like, here's another rockstar developers, you just got like sort of the average developer that's picking up this application and trying to figure it out. Like, it's hard to trace through large code bases from large teams sometimes. So, some people say like, Node for all the things, right? And there's some companies even out there that like, they're very focused on building everything they do in Node, and like all the power to them. I just got to get other shit done. Like, and honestly, I'm thankful for them because they've really pushed the boundary of Node in certain places. Like Voxers really pushed the boundary of, and bringing up when there was like all this deficiency in performance in HTTPS, like an SSL and Node, and they were really advocating like, hey, we'll pay somebody if they'll just come along and help us fix the problem. And that's awesome. It moves the platform forward, moves the community forward. It's just, I'm in a situation where it's like, I need to get things done. And again, like on that curve, I'm trying to find ways to get things done and my teams to do them faster. Otherwise, it's very nice, right? It's awesome. Like, if you look on that curve, did that answer the, like, where is it not a good thing? You can still call bullshit. Even if you don't want to follow up, you can be like, bullshit. And we could keep track, like, tick marks up top if you want. Okay, so I'm going to, like, transition into this, sort of the ways that, that we've used Node. So the first one I mentioned is around aggregation. And this one's kind of straightforward. So assume that you have a client, like let's say it's a browser client that's making calls over WAN. You're making those to several different APIs. And the first call needs to happen before the other ones can. And then you make these 3 other calls. And the reason you don't make all these, let's say in this case, at the same time is the browser blocks you because it only opens so many connections per origin. So maybe you have to wait for those to come back. And you make the other ones. And like, if the overall WAN latency is 30 milliseconds, and like in this case, this is kind of a simple example, the overall latency is 900 milliseconds. Well, if you put something like Node in the middle that is sort of fronts your sort of LAN type latency, then, and if all that really boils down to one, like you're not really doing anything on the client, you're just waiting to make all these requests, in sequence in some cases, then, if you push that off to something that's more on a local network, like, and this is the great use case for mobile, right? Like that, and LinkedIn's had great posts on this, and Walmart Labs and some others, and this is sort of what they do. They have these Screenbased APIs where they minimize both the number of requests that minimize the overall latency, as well as what's returned from the client itself. Because you may not need all the payloads of everything coming back and forth from each of these. Hell, at the end of this, you may just need like an array of IDs or something. So why waste all the bandwidth and save it? So in this sort of simple contrived example, one WAN call, and then if there's 10 millisecond latency on a LAN, then you make that first call, you wait, that's 10 milliseconds, assuming that the time to sort of do any work is negligible. And then you can make those 5 in parallel, and you wait for those 5 to come back, and the overall latency is like 320 milliseconds. Like, this is the place where we've used Node a lot, and it's made a huge difference. It's given us the ability to really to do caching at this level, to do whatever we need to do to sort of try to make our app more performant. A lot of times it was Band-Aids, or like this API is like too granular, or we have to do like this weird ID correlation between things that we don't want to expose to the client. Because like the less you do of this stuff over here, the simpler you can make your client code in the browser. So in the browser, you're in this situation where you've got to support all these different things, right? All these different browsers and runtimes. You've got to support different devices. You've got to support different networks. And like, there's so many different dimensions, right, of things that could go wrong. The smaller your code base is here, the less problems that you sort of naturally have, right? The second place we've used Node is in having that like edge tier client server. We created this concept called app airdrop. And so the idea is, let's say you have a single page type client-side app, and you're using Backbone or some framework that does URL-based routing, whether it's Hashbang or the HTML5 push state, that when your server needs to be able to support, if you're using like push state style things, that initial request. So if it's like /profile /some ID, your server needs to be able to serve that. Like the dumbest way to do it would be to say, no matter what request I get, just return index.html and let the client figure it out. Like look at the URL, then route the views. So instead what we do is we get that initial request for the page from the browser, and then we look at it. And we have intelligence on our server tier to know just as well as we do on the client tier, like what that is, like what it really means, and what are the primary calls we need to make for data to fulfill that. So then we get that first request, we make those calls, and most of those we can do all in parallel. And I guess, again, these are only the primary things. Like we have a bunch of like ancillary, secondary stuff that we'll do on like follow-on requests. But the things that are absolutely necessary and required for that page to load, we'll go get on the fly, wait till that comes back, and then we end up serializing it in JSON, and we just serialize the payload of that into the page and return it. Gzipped back to the client. And then we have we actually use the state machine, this library from a guy named Jim Cowart called Machina, I don't know. He's from like Tennessee, I don't know how he says it. But and that sort of helps us with our like as we construct our app, right? And if it gets to the point where it's like I have to load this component and look for data, it knows if it's already there and it's been deserialized and loaded, it doesn't have to make that AJAX request to get it, and that's how we abstract it. Because if you navigate to that view, if you're in some other page and you navigate to that view, then you're going to make and you don't have the data, you end up, you make the AJAX request and get and load the data, and sort of like from a state machine perspective, like you end up transitioning states. Right? But otherwise, you already have it, and it saves like multiple round trips, and it gets you to the point where the end user sees the primary piece of your application a lot faster. We could go another step further and actually templatize it on the server, but we thought this was like a nice trade-off between like exposing all the templating type logic on the server tier, and we really wanted to keep that tight and consistent on the browser side. That no matter if we got it, if it was sort of there sitting for us, or we got it via an XML response call, or we do other things where we get it off a socket, like WebSocket, and we end up doing data that way. So. Another example is this is a streaming example where we've actually done we've got this backend service, and we've done this both for we have one of our own services. We've also done this for S3, like S3 supports like chunk encoding type requests, where we'll do streaming, file resizing on the fly. Like one of our services, they made this stupid, whatever. So they made this requirement. I think it's like 25K. You can upload a 25K profile image. 10 minutes? Like a 25K profile image, and that, what are you going to do with that? You can't expect the client to they take a photo on their camera and resize it. They don't. What are they going to do? So in this case, we can stream it, and we can accept a 5 meg image. And that sort of comes into our tier in these little chunks. And then with graphic magic, we call out with Node on the shell, and we end up resizing. It accepts the streaming API, and we resize these individual bits that then get streamed. So we don't have to buffer the whole image. We don't have to wait for the whole thing to be loaded before we resize it. We can basically resize it at the speed that you can upload it to across both those boundaries. Another area that we've used it is this thing called Spindrift, which I don't really want to talk too much about because I'm running out of time. And two, I really want to open source it, but apparently, like at my company, it's really difficult to open source things based on the name. Like we're a publishing company, and if it's ever been like uttered, written, conceived to be written but not written yet, they have a problem with, like legal has a problem with the trademarking. So we need to find a name for this that hasn't ever been sort of uttered or mentioned before. But so what we do here is we've built this we have the whole infrastructure, like sort of DevOps style infrastructure of deployment where we use Puppet in the background, we use Fabric for app deployments. But the piece that does, like, when your app is deployed, we use, the core is this thing called Port Authority, which uses Cport internally, which is one of the Substacks modules, sort of this, like really light in-memory registry. And when our app instances come up, they register with Cport. And that includes, like, not just Node apps, but also Java apps as well. And we actually have some .NET apps, too. Because it's basically saying, like, I'm this thing on this host and this port. And then we have, instead of picking one of the Node-based proxies, because we wanted to pick areas of our infrastructure to say, where can we pick something that's hardened and we can rely on? And where we could do that and we were happy with it, we did that. So we chose to use HA proxy as a proxy layer, but we created this like sister node process to it that had a RESTful API where you can actually set up like front ends, back ends, and these pools. And when those things change, so you bring up a new server, you tell it, hey, you're now interested in version 2 instead of version 1, it actually regenerates the HA proxy config and then reloads the process. And HA proxy has this function where it'll do that without dropping any connections. So it actually starts up a new process, it like hands the file descriptors over, you don't drop any like in-flight connections, and we can roll over to a new version of the app, seamlessly without impacting the user, which is really important if we're going to deploy like really frequently, like multiple times a day. And then rollback is super simple as well, because what we end up doing is we always spin up new instances when we deploy, so we leave the other ones up. So if we need to roll back, we just cut it, and then based on what's currently registered in Cport, that version, it flips over and starts routing traffic there. We use it for dashboards and metrics, Graphite, also WebSockets and fallbacks. Everybody's heard the Node WebSocket talk, so I won't give that one here. I guess I'll skip past. The one coding example I have was this like Evaluator I created for Reveal.js projects, which was like you could have some inline snippet here, which is a content editable region, and then you could click on Run DMC, and it'll run. So it's obvious, like what else would you have Run DMC in a presentation for? So then you could actually edit this in line, right? You click on Run DMC, and it doesn't like that because it's kind of bogus, but you can do other things. So it makes it actually easy to like do a presentation like this with a bunch of code snippets. You can actually execute them and see the results. And that turns out to be pretty simple when you get down to it. So the code for that, I guess I'll probably breeze through this, but you get this really simple client that sends that code, that like serialized code, to your server tier, that then actually spawns a node process, executes it, and sort of returns the output, standard error and standard out, back to you. So I'll post this if you want to take a look at it. It's actually kind of clever. It's like the thing you would never ever do, like, and expose to the internet, right? Like, never, right? Like, it's this thing you'd be like, hey, we're going to give us your code and we'll spin up this node process. Yeah, what could go wrong? What do they do? I mean, even if, like, you could set a timeout in here and it'll never return, or, you could obviously make requests, you could do all sorts of things. And, like, depending on where it's running, it has access to, whatever that has access to. So I'm going to go into, like, a series of really quick sort of tips and insights. I had this whole other section I knew I wouldn't get to, but one of the points of Node that I like to tell people is, like, realize that you're not in the browser anymore. Like, you can do things. You're so, like, I was always so used to being so bound by, like, oh, I got to support IE7. IE7 can't do this, or now it's like IE8 and IE9. It's like this elephant that was raised, and beaten in, like, circuses and stuff, and they're tied to these little stakes that they could just easily pull out. But as they get bigger and they get conditioned to being so abused that they just never really do it, so they're pinned down by it. So there's a bunch of things like ECMAScript 5 type stuff that you never, like, I use underscore all the time for this stuff that I could use Node for. There's things like object.seal and object.freeze and awesome features like that I never even think to use because I'm, like, so conditioned to, like, writing things in the browser. And then there's, like, Harmony preview stuff. So if you kind of look, there's a bunch of ways, and this is really to turn on flags in V8 so you can actually run some of the Harmony features in V8, including things like collections like maps and weak maps and that sort of stuff. So like I said, I'm going to breeze through that. And then, okay, so here's the sort of tips and insights. And I didn't want to, I've done presentations in the past where it's sort of been the similar things. It's actually been like, Daniel Shaw has a really good presentation where he lists a bunch of the stuff that I listed in the previous presentation. But the usual suspects of these are things like setting the global agent max sockets thing. So Node by default pulls connections to certain hosts, and it'll by default do 5. So if you want to make more than 5 concurrent requests to any one origin, you need to set that higher. The ulimit thing, which is number of file descriptors on your OS and Linux. There's things like, you want to make sure you catch uncaught exceptions, setting up REPLs and stuff. If you want to dive into that, click on that link. There's a good presentation for that. So then beyond that, here's some specific examples of issues that we've had. And this one's kind of recently. So in that case, we say always catch global exceptions. And you catch it, you log it, you throw it, and you restart your app. And you use some process monitor like Upstart or Forever or whatever that'll do that for you. But you got to remember that whenever you do that, you're hosed. That process is hosed. So any in-flight connections, we'll see problems like this creep up in a deployment. But every once in a while, something will happen, and it'll be something unforeseen. We'll be calling this API. We get this response that we never ever expected, and we'll get this undefined reference, which is typically the thing that always happens. If it's not an I/O thing, it's an undefined reference. And that happens, and we catch it, and we log it, but our process goes down. The next thing we know, we start getting all this these bugs reported that are sometimes this doesn't load and that doesn't load, and it's all because any request going in that process failed. So anything that could have ever been happening could possibly have failed at that point in time. And it might not be your request that failed, but you were hitting the same process as someone else did. So be diligent in watching for these things. Definitely log them, but look at the logs and fix them when they happen right away. The other thing we do is when we package Node apps, we build, and sort of the tarballed package that we deliver actually has the Node binary with it. And we build that and grab it in sort of our deployment pipeline automation based on the engines.node property in our main high-level app. Because it lets us then, we reference it relatively when we start the process up, and it's a really much clearer sort of node dependency. We don't have to worry about what's already on the machine and what's running and where it's running. And then in cases where, again, we do spin up new instances for everything, but when we want to roll back something, and if we want to increment even the version of Node in our app deployments, we can just do that by upping that property in our package.json, and it'll get that version of Node. And if it doesn't have it, it'll build it and then get it and package it. So it's been pretty valuable and eliminated a whole bunch of weird issues that kind of crop up that you're oh, we didn't think about that. I'm almost done here. So the other piece is, again, deployment. I kind of talk about this a little bit, and the Spindrift stuff, or the thing that the HTML strike, which is still in use today, apparently, and that I got to find a new name for. And that idea of provisioning instances every time is sort of really powerful if you can do it. If you're going to deploy in the cloud, and we deployed a lot to EC2, having that ability to do that has made failover much easier. It's made doing post-mortem on things. So if we have a problem with something, we can spin up new instances, take this one out, and sort of leave it, and then either go back to it at that point in time, or if you can't get to it, leave it up until you can get to it, and that's been really valuable. Visibility into things, client-side, both client-side and server-side, instrumentation and metrics. In all of our Node things, we tend to instrument any call coming in and out of that tier, and we use Graphite and Stats to do that, to aggregate it. We also do client-side metrics for that, so we have Node routes and our Node apps that end up reporting that to Graphite and Stats. Things like user-perceived load times, where we could look to see when was it actually put in the DOM. Log aggregation. Since we spin up new instances and those old instances go away all the time, our logs go away if we don't actually aggregate and push them somewhere. For that, we end up using Logstash to format them, and we use Graylog as a destination. And then introspection. And you got things and this is still a challenge today, and there's sort of better tools coming out. There's a lot of work being done. I mean, if you're on SmartOS and Joint, you've got flame graphs. That's awesome. If you're not, it's sad, right? And we're not, for various reasons. But there's Node VA Profiler with Danny Coates' Node Inspector stuff. There's also Node Time and then Nodefly, which are these services that do node call analysis that you can just require in those services and it sends data to. Node Time, I'm not very happy with because it sends all the headers of all my requests, I think, or at least the URL. So if I have access tokens and stuff on URLs, and it's getting sent over the wire to them. Nodefly I used, and it's just in beta, and it's free to try out, but it was cool because it does things it'll tell you what the biggest offenders were, longer running functions, who's blocking the event loop, and for how long. It breaks things down by database access, Redis, and some just native Node things, and it's just sort of really helpful. Things that you don't have visibility into otherwise. If you either thought to track them or not, it gives you access to it. It's the same type of tooling that is available for bigger stack things you expect on Java and .NET and all those types of analysis that is coming along in Node. Another great one is by, I mentioned Lloyd, but he has this module called Node Memwatch that you can do heap analysis and heap diffs and stuff, and it really gives you a really great picture into what's happening in your heap in Node. I won't go into the private Node registry. NPM is, if you do a lot of NPM, like private modules, and like we have a big organization with lots of people. We have, I think there's 7 teams, like just in Denver doing Node development, like 7 full-on teams doing Node development. We have lots of modules. We probably have like a couple hundred modules, and each team sort of decide to do their own thing, and we're trying to converge that now. But there's sort of issues with a lot of the different approaches for whether you do a private NPM repo that syncs from the public one, or whether you do things like, you can resolve modules in NPM out of Git. We've done that, but then everybody needs sort of SSH-based access to every module and every module dependency. And I've kind of created some experiments. I created this one. This is one of those, like, my 4 open source projects, Node Reggie, which is just this really simple thing that has a sort of Semver-based convention in the URL scheme to load Node modules by tarballs. We're using that a bunch in certain places, but I think we're going to transition off it. But there's some just deficiencies in that. I'm about done. This one's actually worth mentioning. So we had this issue, and this was a couple weeks ago, where and this is from like some of our dashboards. Now you can't really see this that well, but we have all these things happening, and this is the same sort of process that does these things. Some call it these Google APIs and some other things, but periodically we're just seeing these huge spikes in latencies on these outbound network calls, and we were like, what is going on? We have this weird, like a network VPN between where internet access goes and some more internal things between Amazon EC2 and our own data center. We thought it might be that. What it turned out to be was we use Puppet, and on Puppet you have a Puppet agent that runs, and our agent runs every 30 seconds. And it turns out, and these were just running on like small. We had a whole bunch of stuff that is covered in beta, not being accessed, and we had them on like M1 small instances in EC2, which have a single CPU core. There's like one compute unit on EC2, and they were starving. That Puppet agent would run. It turns out it does like an MD5 hash calculation on a whole bunch of files at once and just bursts it. It does it pretty fast, but when that happens, it just starves the CPU from this node process. So it's like you really need to be aware of what else might be running on that box. It's not so much to say, well, like, I'm going to start as many node processes as CPUs, and I'll be fine, right? Because even if you have these blips, like your end users that happen to hit that process at that time are going to have a problem. So what solved this was we just spun up bigger instances with more cores, and we end up spinning up one less node process for the core on those ones that are multi-core, which is probably more than enough, but at least it should give us more consistent access times. I'll mention that. This one's neat to mention. You have these cases, you have these one-liners in Node, like you have like with requests, you see this like in the docs, where they're like, hey, look, you can do a Node proxy. The proxy is a whole other server in like a single line for like gets or something, right? And you're like, sweet, I'm going to do that. You have this weird use case where you're like, I guess Node app, and I got to proxy this one thing. And it's fine. In like happy days, happy path is fine. And then you have these global exceptions that are thrown when it can't connect to something, when it times out and it blows up your app. And that's one of those times where you get these uncaught exceptions. Again, it's like, it's not as simple as these little things. You have to catch the errors either on those individual requests at the server levels up above, but just be cognizant of those bad things that can happen. And thanks. Sorry, I kind of went a little over, but.
All right, so if you have a question, just raise your hand. I can hand you the mic so we can hear what's going on.
You said you package everything into a tarball, including the node binaries. Doesn't that take like an hour to an hour and a half to build the node?
They're already built.
Oh, okay.
So we take a pre-built package of Node, and we just bundle that with our tarball. I mean, we have to transfer that over the network. It takes a little bit longer. Like, things are a little bit longer, but it's that level of reliability that we can take that. And even if we deploy on like this Puppet infrastructure that makes sure everything's consistent and it should be there, but in some cases where we need to deploy that to we have like some VMware environments or this random thing, we know that we can pretty much take that package, and if it's Ubuntu, we can lay it down and run it, it'll work, and we have to worry about a lot of the underlying things.
Anyone else? No? Nobody? Oh, you have another question?
How do you, or I can just probably ask this later, how do you package all that stuff? Or
yeah, so we have, it's a bunch of custom scripts we ran. It's a combination of, we do some things in JavaScript that are sort of application specific. We do other packaging in Python. We use Fabric to do our app deploys. So we have these Python scripts that'll do a lot of like some of the just general like tarring up of things and transferring them to the servers. And we've got some libraries we've written in Python that we end up using, like things to interact with the Amazon APIs that are just common to provision new instances, and that's just wrapped up in these reusable Fabric tasks.
Yeah, so I have a question, actually. Yeah. You were talking about the requests that come in, and then you zipper out several separate requests to different APIs and things, and then when they come back. Are you using any kind of async libraries or anything to keep track of like when those happen?
Yeah, so we use requests to make the calls. We use async a lot for the things that we say, like these things happen serially and these things happen parallel. We haven't really used domains yet in Node, like that came out in 0.8. We just haven't made that transition yet. But we typically use async, and that's been working pretty well for us. And we can, there's like a function in the request library that actually was one of the contributions that I made, which you can specify a timeout on the request. You can say like, if this thing's going to take longer than 2 seconds, I can actually set that on the request. And if that times out, you'll end up getting one of those timeout like errors, and you can check for that and return a partial response. Because sometimes you're like trying to serve this body of data, and you have this one request that you're like, it'd be awesome if we had it, but if it takes, I don't want it to hold up our entire payload of that, one sort of request and response conversation. So we'll return a partial response in some of those cases.
Any other questions? Cool. Take a few minutes. There's tons of pizza left, so eat that, and we'll get John Bender set up here.
Thanks, everybody. Appreciate it.